Okay, we're going to do equilibrium today on reversible reactions. So really nothing new. You guys did this last year. So first of all, this is called the Chatelier's principle. If a system, it says that if the system is at equilibrium and it's disturbed by some sort of change, the system's going to shift so that it can partially counteract that effect of that change. So it wants to reestablish equilibrium. We used that teeter-totter analogy last year. We're going to use that again. That'll kind of help you figure out if you're going to shift forward or reverse so you can reestablish equilibrium. So let's look at changes in concentration first. So adding reactants will add to the left side of the equation. So that'll make it not at equilibrium anymore. So it's going to have to shift forward to make products, meaning shifting to the right, shifting forward, shifting to create more products. Removing reactants will do the opposite. It's going to want to make more reactants, so it's going to want to go reverse, go back to the reactant side, shift to the left. Adding a product will cause it to shift left also, to go back to equilibrium. So you can say it's shifting reverse to reestablish equilibrium. And then removing a product will shift it forward to make that product, meaning shifting it to the right. And remember, if you add or remove solids and liquids, they have no effect on equilibrium. You're just looking at solutions, aqueous solutions, and gases that'll affect equilibrium. Okay, so we're going to try this one. You have this equation of carbon dioxide and hydrogen, making carbon monoxide and water. So what would happen to the system if you first remove steam and then second, carbon dioxide is added? So go ahead and predict what would happen. Okay, so if we remove steam, that means I'm taking away water, because water is steam, so I'm looking right here. And so that means I'm going to shift. It's going to shift forward to make that product. Carbon dioxide is added. Carbon dioxide is a reactant over here. So there's too many things on the left side. You can think of it that way. So my teeter-totter is heavier on the left. So it'll shift forward to reestablish equilibrium. So it will also go forward. Oops, going the wrong way on this. All right. What would happen to the amount of reactants and products if this were to occur? So if it's going forward, that means I'm making product. So the amount of product would increase. In order to make the product, the reactants have to react. So that means they're going to be used. Reactants will be used to make products. So the reactants will decrease. Okay, and another thing that can affect equilibrium is changes in volume. Reducing the volume favors the side with the fewest number of gaseous moles, because you're making the container smaller, so fewer things can fit inside there. So the reaction will shift to make fewer gaseous moles in that equilibrium system. And then this also affects the pressure. So if you reduce the volume, making it smaller, actually the pressure increases. And so if you increase the pressure, again, it's going to go to the side that has fewer gases to kind of offset that increase in pressure. Okay, so here's an example. So this is the other opposite. So increasing the volume would make the volume bigger. So that means you can get greater number of moles, greater number of particles in that container. So it'll shift to the side that has the greater number of gaseous moles. And then same as if you're decreasing the pressure. So decreasing the pressure kind of gives more room for the gaseous moles to exist. So it'll go to the side that has more gaseous moles. Okay, so here's another same example. So we have carbon dioxide and hydrogen making carbon monoxide and water. And it says this reaction is contained in a 4-liter flask. If a new flask is used, the volume is increasing to 8 liters. They want to know in which direction will the reaction shift. So go ahead and make your prediction. All right, so on this, no shift would happen, so no change in equilibrium would occur, because if you notice on the left, I have 2 gaseous moles on the left, on the reactant side, and I have 2 gaseous moles on the right, on the product side. So they're exactly the same. So if the gaseous moles are the same on both sides, it will have no effect on the equilibrium. Okay, temperature. There's 2 reactions that temperature will affect, exothermic and endothermic. So in an endothermic reaction, that favors an increase in temperature because you're adding heat in. So remember, if your delta H in your equation is a positive, that means you have a endothermic reaction. And then that's going to cause the reaction, again, to shift forward because that's favorable. It's going to make more products. And then a decrease in temperature favors an exothermic reaction. Exothermic reaction means it's giving off heat. So heat is actually a product. So again, if your delta H is a negative, that's going to indicate that's an exothermic reaction. So to get that reaction to go forward, you need to remove the heat, remove that excess heat that's being generated. So decreasing the temperature would cause the reaction to go forward as well. Okay, so here's your next example. You have dinitrogen tetrahydride and oxygen reacting to make nitrogen and water. This is a delta H of negative 150 kilocal. And I want to know if the temperature is increased, what would happen? So go ahead and make a prediction. Okay, so this is a negative delta H. That means it's an exothermic reaction. So if temperature is increased, that's going to actually, like a teeter-totter effect, I have more heat on the product side because heat's a product in an exothermic reaction. It's going to shift the reaction, to the left. It's going to reverse it to reestablish equilibrium. So again, the reaction is exothermic, which favors a decrease in temperature, not an increase. All right, so for more practice, you guys go ahead and go to this link. This is Science Geek. There's like 20 questions you can practice on. So you can either use the QR code or you can go to the bit.ly and try those problems. And then when you're done with that, you can go ahead and work on the review on equilibrium. And then you have book work as well. All right, enjoy. We'll see you guys later.